So, hello everyone, good morning. Um, let's start. I guess people connecting late will join and catch up. Um, so that's good because we have people registered from different countries, from France, of course, from Colombia, England, Turkey. So it's very nice to be able to have all these nationalities connecting. So today we're going to talk about resource optimization. Um, and before we dig into that, I want to come back to the different steps before going to resource optimization. So the objective of our tool set, PragmaDev Process tool set, is to help BPMN modelers to verify and optimize their models. So I insist on the fact that before you optimize it, you are supposed to verify it. That's why I have this slide. So if we go through the different steps for the optimization of the business process, we have four major steps, as you can see there, from static analysis to dynamic execution, exploration, and optimization. So the first one, static analysis, is to get the model as a static model. Do not care about the dynamic of the model yet, but make sure that the model is properly constructed. Does it have a start symbol, end symbol? When you send messages from one participant to another one, are they properly connected? Do they have the same name, basically? Uh, and that's very important because when you have a big process, it's not only one people writing the process, it's different people writing the process. So when you put the different pieces together, this first static analysis is very important. And the standard, the BPM and standard, list a number of static analysis you must do before moving on. Um, our tool is an editor, but also the model itself can come from an external tool. And so, for example, I have here the example of OPEX, which is our, because Mega is our partner. So it's another authoring tool, but it could come from any other tool. We have built a connection to external tools to ease the integration. So, for example, you can call our tool from the outside. If you do in that mode, we cannot modify the model because the editing tool is not ours. We're just there to get the model and do our dynamic and static verification. But also, if you have a problem, if you find an issue in your model with our tool, you can come back to the initial model in the authoring tool. So we have built that in the tool. So that's the first step, static analysis. Then we move to the dynamic execution. That's really like the key feature when we developed our tool was to do this dynamic execution capability. So based on the execution semantic described in the standard, we can do step by step in the model. And the idea here is to make sure that what you wanted to express is properly expressed in the model, because sometimes you write something, you think you're writing some dynamic, and actually the execution is different from what you expected. So this feature will make sure that it's exactly what you want it to do. And when you do that, you can have execution traces, as you can see on the right. And these execution traces are scenarios you can save and replay later on. In addition to that, you have coverage information that allows you to make sure you have been through the different paths. Static, dynamic, but once you have the dynamic, the tool can also explore. That means it can, does not have to, but it's a possibility to try all the possible path of execution. So we partnered with Insta Bretagne, which is a research lab in the west of France, and their tool sort of drives our execution engine, and tries all possible execution paths. So that allows you to find automatically deadlocks, uh, find unreachable path, but also verify properties, which means pieces of scenarios that should always be true or false, whatever happens in the system. And now we have introduced in version 2 simulation capabilities. So that means you can add statistical information in the model and say each activity will take this amount of time with the statistical laws. And once you have defined that, you don't drive the execution. The timing information in the model drives the execution, because if you said that this activity takes 1 minute and this one takes 5, of course this one will end first. So you cannot choose which one will end. So this is in automatic mode. So far we have introduced statistical information on the models based on the BPSIM, which is a de facto standard in BPMN simulation. And now we have introduced resource, and that's a very, very important aspect of the model, of course. So let's see how that goes on a real model. I'm using as an example our classical pizza demonstration. So in this example, I'm not sure if everybody knows about it, so I'll just make a quick explanation. On the top here, you have a customer who's hungry and who'd like to have a pizza, and on the bottom you have the pizza restaurant. So the customer goes through a number of steps, which are not that many. So first he orders the pizza, and then he waits for the pizza. So either the pizza does not come after 30 minutes and then he will complain, or the pizza arrives and then he pays and he's satisfied. On the other side, in the restaurant, you have 3 lanes. One is clerk that answers the phone, takes the order, and might also calm the customer if something goes wrong. Okay? Once the order is taken, it goes to the chef, prepares the pizza. So the chef prepares the pizza, bakes the pizza. When it's baked, it's given to the delivery boy, who goes to the customer, delivers the pizza, get the money, and we're done. So if you want to try the execution and just to show make sure that this is correct, you can do this step-by-step execution. So first, you're hungry. So you see the blue thing is the only thing you can click on. So you order the pizza, and here the order has arrived, and so on. So that's the step-by-step we have introduced, and make sure that everything we do here is correct to deliver the pizza. Pizza is arrived, you pay, satisfied, and here you go. So that's the basic execution, the step 2. And so once we have that, you can add timing information. Okay, so to do that, you need first to define what we call scenarios. So here we have 2 scenarios. One is electric bike, and the other one is with the classic bike. So we will only have a difference on how we deliver the pizza. Okay, so that's the key thing we're gonna play with here. So either I deliver with a classic bike or with an electric bike. And for each activity in the restaurant, now I can say it will take time. Huh? So if I take the order and I look at the simulation properties here, I can see that it's around 5 minutes with a standard deviation of 1 based on normal distribution. And so for each activity, we have different timing and different maybe distributions, like a triangular distribution here, for example. So and so on. And that is for the electric bike. So you can define different timing for the classical bike. So now we are introducing the resources. So the resources are defined here. Okay. And we have three resources: a cook, an oven, and unqualified. An unqualified employee. So it can be anybody. Do not need a specific training, like for example, to deliver the pizza or answer the phone. Maybe you need a bit of training, but okay. Let's say you can hire anybody, and it will work. Um, so these are the resource, and we also have to define the roles. The roles is uh, either you're a chef, or you act as a chef, I should say, you act as a clerk, or you act as a delivery. So if I go back to the resources, for each resource, I can say which roles the resource can play in a way. So the cook, of course, can be a chef, and is probably the only one able to be a chef. But actually, he could also be a clerk. Huh? So if nobody else is there, he could answer the phone and take the order. It's possible. The unqualified, on the other hand, cannot be a chef. Huh? He cannot make the pizza, but he could either answer the phone, so he could either be a clerk or he could deliver the pizza. Okay. Um, so you see we are playing a bit with the roles and on the number of resources we're going to have. So the quantities we will have here, for example, is that we'll say that the default value for the unqualified is 1. So we only have one guy who can answer the phone and deliver the pizza, and we only have one cook. Here it's like the resource is always there. It's always one. If you want, you can define calendars and specify when the resource is available or not. Okay, so for example, if it's a machine and you say, oh, maybe it has to be revised every 3 months, you can introduce that in the calendar. Okay. So anyway, let's start with this. And now for each activity in our BPMN, we can specify who's gonna do the job. Okay. So for example, to take the order, if I look at the simulation properties again, in this section, I will say that for this activity, I need a resource. So I can specify the resource directly, or I can specify a role. So here we'll specify a role, and we say here I need someone who can take the role clerk, who can basically answer the phone. Okay. Same. Oh, I have specified. Sorry, 1 here. Same thing for this count customer activity. I can say role clerk again. Okay. Now to prepare the pizza, it's not the clerk I need. It's the role chef. So I need one chef. But to bake the pizza, I don't need a role. I will just say I need an oven. So I won't use the role thing. I will directly say I need the oven. Okay. I could have said, okay, oven can, I don't know, cook or heat, whatever, and as a role and play on the role. But just to show you that you can also address directly a specific resource, not based on the role, but based on the resource itself. So here I need an oven. To deliver the pizza, I need a delivery role. Okay. So I should make sure I put one, of course, very often we forget to put one here. Yes. Okay. Um, okay, so we have now the resource allocation for each activity. Um, Now, we're going to run a simulation, but one of the interesting information we can retrieve from the simulation is what we call the lag time. That means an activity being waiting for resource and how long. So we will add this information to each activity here. So it's in the time parameters. I go to advanced instead of the basic one we showed here. And I will ask for the lag time result. So the average lag time result for each activity. Because in BPSim, in the simulation information I put in, it's input information as well as expected results. Okay, so I will add that to each activity here. And that's actually something we're because here you have to do it for each activity, so it might be a bit annoying to do. We are considering, to ease the editing of these parameters, and maybe do a bulk allocation or bulk property for all the different activities. So anyway, we don't have that many here, so it's okay. Now also we have to define the triggers. Okay, if we look here, this that's really the beginning of the scenario when the customer is hungry. We will put a trigger count. So we will say we will repeat the scenario 30 times, and the time between each scenario is 10 minutes. So that means we're going to order 30 pizzas and one pizza every 10 minutes. So that's like a 300 minutes scenario long. Okay. So that now we can really start the simulation. We select both scenarios, classic bike and electric bike, and launch the scenario. So as I said before, everything here is automatic. And you see here that first you have 600 what we call processes executed. So some of you might wonder, well, if I have 30 times 10, that should be 300, not 600. That's because you have two processes, okay? One for the customer and one for the pizza restaurant. So since both of them are launched, that makes 600 for the classic bike and 600 for the electric bike. You can also see as a result that there is no timeout in the execution of the scenarios, and there is no deadlocks either. So now we're going to save the result here. So it will save the results for each of the 600 scenarios. So that means that you can replay any of the 1200 scenarios we have basically played. Okay, so now we will open the results here. Okay, so I open the results, and actually you see the same thing. It's the same BPMN, except that it has put in the background the result of the different execution. So one of the key quality indicator in our scenario is how many times did we have to count the customer in our different scenarios? Okay, so if I look at the count value of the count customer, I can see here that in the classic back scenario, I had to count the customer 505 times, and with the electric bike scenario, it's 220 times. So if you think about it, it's like 220 times out of 300 scenarios. So that's very bad quality, because that means basically they're always calling, and maybe several times for each order, about where's my pizza? What's going on? So it's very bad result we have to fix. So now if we look at the different activities, we can also look at how long the activity had to wait for the resource to be available to continue. That's the lag time we talked about. So if I look at take order, you can see it has to wait like 90 minutes, which is very long, and almost 6 minutes for the electric bike. So I can check it out for each activity and you see how that goes. Okay, so that's very bad, like 22 and 6 here. Oh, bake the pizza is good. It's around 0, so we don't have to wait for the oven. It basically means the oven is not a resource issue. It's not a bottleneck here, where the others are bottlenecks. Huh? And this one is probably the worst, like 36. So this is very bad result we have here. So since you can also see the details of execution. You can replay the logs and you can look at the usage of the different resources you see, like between the cook and the oven and so on. So you have all this information, but at least with the basic lag time, we cannot see that there's one resource missing. Okay, and since they deliver the pizza and take the order as are waiting a lot of time, we will change our scenario and say, okay, so the unqualified guy, I need another one. Okay, so I will change the quantity here, put it to 2. Okay, and run the simulation again. Okay, so go through all scenarios, save all the results. As I said, all the 1200 log scenarios you can replay afterwards if you think there's an issue, and then you can open the result here. So what about the counting information about count customer? That's much better. We went from I think 500 to down to 160, and here it's 12. So it's much better. Now, if we look at the lag time for each activity, oh, 0.6, so it's basically 0 here. We don't basically have to wait for the unqualified employee anymore. Huh? Straight away you get it. Same to prepare the pizza, same for the oven, same for to deliver the pizza. It's like less than a minute. So it's that's pretty good. So we don't have a resource issue anymore now. We know that. That's for sure. Still, we have an issue with the quality because the number of people complaining with the classic bag is too high. So that means that the resource organization I need in my restaurant is that I need one cook, 2 unqualified employee, but also I need electric bikes to deliver the pizza because otherwise the quality is bad. So that's how you optimize, on a simple example, the resources. So you can see how simple the example is here, and how tricky actually it can be to measure, how many resources and I should put in my process, and what kind of quality can I expect from that. Okay. So we kept it simple, but if you look in detail at the different resources, you have different attributes. One of them is the unit cost factor, huh? Because different resources can have the same role, but different resources can cost differently. And one of the reasons for that is that because for each role for the resource, you have a time factor. So some resources will go faster than others, but will probably be more expensive. Okay? So you can introduce that information in the resource, and it will appear in the results. And that will help you to optimize the different resources. So that was like let's say an introduction to resource management, and I hope it will give you ideas in your daily work. But this is very new, and even though we have been experimenting a bit, we are waiting for, of course, a new use cases. So that was like my presentation. So if you have any questions, please ask them in the. I think you should have a question section somewhere.